Good evening. Now we will see the other method. So we have seen we have three methods for solution of this differential equation. So now we are with third method. Direct method we are not going to learn over here because in that we have a lot of integrations and therefore we will go for this method of variation of parameters. So short method or shortcut method we have seen, and now we will see the second method. In short method we have seen we have three cases. We can have e raised to ax, then we have sin ax cos ax, and then we have x to the power m, x to the power of m, and then we have seen we have combination of these e raised to ax and e raised to x, x raised to m, and then we have one combination of these two. And then we have one combination also, that is x sin x or cos x. So we have seen all these direct method which avoids integration. But in method of variation of parameters also we have integration over there. Now we can see over here. So we have this differential equation a d2y by dx square plus b dy by dx plus cy equal to x. So now the problems which are related with your sec x, then tan x, then cot x, these we cannot solve by direct method. So such problems which cannot be solved by this short method, we have to go for method of variation of parameters. If we will go through the question paper, they are going to mention for some problems use method of variation of parameters. So we have d2y by dx square plus b dy by dx plus cy equal to x. Let we have complementary function for this yc is equal to ay1 plus by2. Then again we have to go, we have to write auxiliary equation, and then we have to find that factors, and then we have to decide in the same way whatever we have for short method. Only change we have in particular integral. So particular integral we have yp is equal to u y1 plus vy2. Y1 we have the value which we are going to get in complementary function, and y2 also we have second value of complementary function. Now u we have to find by using this formula minus y2x. X we have the part which we are going to say that is q in problems before this, and therefore we have this, you can write x or you can write this as q, which is on right side, into dx. And then we have v, that is y1. Then again you can write it qx, or if you are familiar with q, that is in short method, you can keep it as q upon w into dx. And w we are going to get it as y1 y2, and below we have in second row we have y1 dash y2 dash, and this known as Wronskian. And this we can find, if we will see this, then we have this as y1 y2 dash minus y2 y1 dash, and this value of w we have to use over here. So now we will go with one problem, that is d square plus 4y, and that is equal to tan 2x. Now first we have to go for a complementary function. So we have auxiliary equation for this. We have dm square plus 4, that is equal to 0. And if we will see, we will have m square, that is equal to minus 4, and then we will get m is equal to plus minus 2i. So now again we have alpha, that is equal to 0. So e to the power alpha x, this becomes e to the power 0x, and this is 1. So we need not require to consider this term which is related with real part. We will directly go with imaginary part, and we will get this as y suffix c, that is equal to c1 cos c1 cos 2x, because we have 2i, plus c2 sin 2x. So in this we have y1, that is equal to cos 2x, and we have y2, that is equal to sin 2x. Now we will first find value, that is of w. And we know value of W that we have equal to mod of y1, y2, and then we have y1 dash, y2 dash. Now we will substitute the value. Y1 we have that is cos 2x, y2 we have sin 2x. And then derivative of cos 2x we have minus 2 sin 2x. And derivative of sin 2x we have 2 cos 2x. And then we will cross multiplication. Then we have 2 cos square 2x minus 2 sin square 2x. And then 2 we can take common, and from this we will get it as sin square 2x plus cos square 2x. And we know we have sin square 2x plus cos square 2x, and we have value of W that is equal to 2, because we have this value that is equal to 1. Now we will find value of U. So we have U, this is equal to integration minus y2 into q divided by w. Now q we have tan 2x, so we have minus y2 value. If you will see, y2 we have sin 2x, so minus sin 2x into tan 2x. Value of w is 2 into dx. Now we can write it as minus sin 2x into sin 2x upon cos 2x, and that is upon 2 into dx. So we will have here u is equal to minus 1 by 2 integration sin square 2x upon cos 2x into dx. Sin square x we can write it as minus 1 by 2 integration 1 minus cos square 2x divided by cos 2x. And if we will separate out this, then we are going to get this value equal to minus 1 by 2 integration of, we have two parts now, 1 upon cos 2x into dx minus cos integration cos square 2x upon cos 2x into dx. Now we will have this cos 2x gets cancelled. We will have this value of u minus 1 by 2 in bracket integration sec 2x into dx minus integration cos 2x into dx. And from this we will get equal to minus 1 by 2 sec 2x we have log of sec 2x plus tan 2x upon 2 minus cos 2x we have integration as sin 2x upon 2. And then from this we will get this value that is equal to minus log sec x plus tan x upon 4 plus sin 2x upon 4. Now we have v that is equal to integration y1q upon w. And now we have y1 we have that is cos 2x into q we have, I will directly write now sin 2x upon cos 2x, that is tan 2x upon 2. Directly I have written this is tan 2x into dx. So this cos 2x gets cancelled, and we have this equal to 1 by 2 integration sine 2x. And we have integration of sine 2x is minus cos 2x upon 2 already we have by 4. And then we have value of yp that is equal to u into y1 plus v into y2. Now u we have minus log of sec x plus tan x upon 4 and y1 we have cos 2x. Sorry, we have one term again. So into cos 2x, and then second term we have sine 2x of this. So we have plus sine 2x upon 4 into cos 2x. So we have multiplied these both terms of u by cos 2x. And then we have below that is sine v into y2. We have minus cos 2x upon 4 and y2 we have sine 2x. And now you can see this sine 2x cos 2x with minus sign. Sine 2x cos 2x is plus sign. So these two gets cancelled. And we have this yp that is equal to minus cos 2x upon 4 into log of, sorry, this is sec 2x plus tan 2x because we have this as sec 2x. So this also sec 2x tan 2x that we have to make sec 2x we have over here. So we have log of sec 2x plus tan 2x. And then we can write y solution of this, and that solution we have yc plus yp. So we have solution of y that is equal to yc plus yp, and therefore y we have c1 cos 2x plus c2 sine 2x minus, we can see this cos 2x upon 4. So minus cos 2x upon 4 in bracket log of sec 2x plus tan 2x. And this is solution for given differential equation. So always make block to the answer so that it becomes easy for the examiner to check the answer. So now we will stop here only. Remaining part we will see in the next lecture. So we have these two methods. Now henceafter we have to only solve the problems. In next video, I will solve the problems from examination and you have to solve it and check it. Now we will stop here only. Thank you.